Welcome everyone to my first full math course here on YouTube. I'm going to be doing pre-algebra, and I'll be using the Art of Problem Solving textbook. This isn't intended to be a replacement for the Art of Problem Solving textbook or course. The materials are very good, just what I happen to be using for this course, but I still recommend buying the textbook. At the very least, buying the textbook. There's going to be some additional exercise problems that I'm not going to cover in this video series, but I highly recommend going through all those exercises for more practice. A bit about myself: I am a homeschooling dad of a advanced, he's 8 years old now. I'm going to be going into pre-algebra here pretty soon, so that's why I'm getting these materials together now. But I figured I'd go ahead and share that on YouTube to see if it benefits anyone else. So yeah, my experience is working with an advanced younger child. So if that is not your situation, I wouldn't say that this series wouldn't be good for you, but just to put it out there from the start, that is what I'm used to speaking to. So anyways, and I'm a software engineer, about 15 years or so. So I am not a mathematician, but I do have a lot of math background. So anyways, let's go ahead and just jump right into it. First slide here is just a little bit about the course. So up here, we got some number lines here. So this arrows, most of you probably already know this, but just figured I'd point it out just to be explicit about it, that when you have this arrow here, it means it goes off into infinity. So even though it's not shown on this number line also includes -7, -8, and so on forever. Same with the other side, it goes on 7, 8, 9, 10, 11, 12, and so on. These ellipses, this dot, 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 means the same thing. It goes on for infinity in both directions. One thing about terminology is that we're going to try not to use terms like whole numbers or natural numbers or counting numbers. Nothing wrong with those terms, but mixing terms could get confusing. So we'll kind of just stick to one term, and that's going to be integers. So we're going to have positive integers and negative integers. One note is that 0 is not positive and it's not negative, but it is considered non-positive and non-negative. So 0 is both non-positive and non-negative, and it's neither positive nor negative. So non-positive numbers would be anything that is not positive. So that would be 0 and anything negative. Non-negative numbers would be the opposite. It would be 0 and then anything positive would be non-negative. Here, there's going to be some icons that some of them might show up on these slides. All of them would show up in the textbook. So if you want to read about this, go ahead and pause here and check out what those symbols mean. So jumping right into chapter 1. So first of all, I am going to break these chapters up into sections. So that last slide kind of just covering a little bit of 1.1, which is the kind of just intro to the course itself. 1.1 is why this course starts with arithmetic, so I'm kind of breezing by that part and going to go right into 1.2. So this video is going to be basically just the intro to the course and the 1.2 section, and then we'll break from there, and I'll break this up section by section. So anyways, this is the beginning of chapter 1, arithmetic. At the beginning of each of these chapters, there's this little 24 game. If you're not familiar with it, it's a game that I was obsessed with when I was a kid, but you're given 4 numbers, and you can use addition, multiplication, subtraction, and division in order to make 24 with these numbers. So if you want to pause and give these a shot real quick as sort of a warm-up to this chapter, go for it. To go over the solutions for these, for the first one here, you can do 7 plus 1 is 8, 8 minus 4 is 4, and 4 times 6 would be 24. What I try to do, my strategy for these is look for 6s and 8s. If you find a 6, then if you can make a 4, you can do 6 times 4. Same thing if you have an 8, a lot of times you can make a 3 to do 8 times 3 would be 24. Also 12 times 2 is pretty common. And different combinations from that. Some of these are a little bit trickier and they don't fall under that pattern, but it's kind of a general rule of thumb of something that you can look for these. So yeah, so that one ends with 6 times 4 there. So this next one here is a couple different solutions for this one. One of them is 5 plus 1 would be 6, 8 minus 4 is 4, and then again, 6 times 4 is 24. This one here is a little trickier. I think this is the hardest of the four. So what I got for this one is 1 plus 1 would be 2. 2 times 23 would be 46. 46 minus 22 would be 24. So that number ends up getting bigger than usual here, going up to 46 and then back down. This last one here, we have 7 times 5 is 35, minus 10 is 25, minus 1 is 24. All right, so now getting into 1.2 addition. So the reason why this book goes through addition, which should be expected that if you're at this level, you already know addition and subtraction, multiplication, division, which is what this chapter is about. But we're going to be reframing some of the things we already know to better prepare for algebra. So that's the reason why some of these topics are being gone over, even though you should already know how to add and subtract and things like that. So the format of this series is going to be, I'm going to show a problem here. I would ask you to pause the video here and come up with an answer on your own. Then we'll go over the answer together and maybe make some tweaks in how we approach some of these problems and the terminology that we'll use for some of these problems. So using the two pictures below, explain why 2 plus 3 equals 3 plus 2. You can go ahead again and pause the video here and see if you can come up with a good answer for this. All right, so as you can see here by these images here, this image right here is the same exact size as this image here. They're just flipped a different way, right? You just flip this upside down and it's still the same size. It still has, if you count the blocks in there, there's still 5 blocks in both of them. It's just oriented differently. So you can see that these are definitely the same. So if you have a 2 first and then a 3, it adds up to the same thing as if you have a 3 first and then a 2. Whew. All right, so yeah, they're the same size, just flipped. So same thing would be the case if you have 10 plus 100, that would be the same thing as 100 plus 10. 45 plus 12 would be the same thing as 12 plus 45, and so on. Any two numbers, any A plus any B would equal that same B plus A. So you don't have to go through and try every single combination to see if it holds true. It will always hold true. We won't go and do rigorous proofs of all of these properties in this course. Some proofs require more advanced math, calculus and such. Some proofs we will kind of do a rudimentary run through, but a lot of them would require more advanced mathematics to go through the proofs. So I would say for some of these, you're going to have to just trust me on that they have been thoroughly proven in mathematics. And if you wanted to go through tons and tons of examples to see if they hold through, that wouldn't be a rigorous proof. We'll talk about what is meant by a rigorous proof a little bit later on in this course. So just testing a lot of things would not be a rigorous proof, but it would give you a good idea that everything you try happens to work out. And that's pretty good news. And I could tell you with certainty that this always does hold true, that any A plus any B is equal to B plus A. This is called the commutative property, that you can flip the order of how you add the two numbers and it will always hold true. Side note, anytime you see a video picture right here, that means that there is a video with further explanation on this topic, and I'll put all the links to the videos down in the description below. So anytime you see this in the bottom right corner, this little image of an icon, thumbnail, then that means that there's a video to go along with it. I recommend you go ahead and pause, go find that link to this video, and then watch this video, because it could help. Even though it's very similar to what I'm saying here, just hearing it worded in a different way could be very helpful. So I recommend going and watching all those videos as you see them come across the screen. All right, so next problem. Using the two pictures below, explain why, in parentheses, 2 plus 3 plus 4 equals 2 plus, the parentheses, 3 plus 4. So you can see that the order is the same, 2, 3, and 4, 2, 3, and 4, but the grouping is different. So go ahead and pause this and see if you can come up with a good explanation about why these two are the same. All right, so in this problem, in the first grouping, we're grouping together the 2 and the 3, so this white section here. So first we're going to add this white section, and then we'll add this darkened section. Versus over here, first we add the darkened section, and then we add the light section. But you can see, once again, just like the first problem, the size of these images are exactly the same. And in this case, they're even oriented the same way. Now, the first time we kind of flipped it. This isn't even flipped. This is just the order that we are adding it. So this is the grouping. This is called the associative property. The associative property talks about how we group these numbers together. So in the first one, this 2 plus 3 is grouped together. And the second one, this 3 plus 4 is grouped together. So we're just changing the way that they're grouped. And the associative property says that the grouping of A plus B plus C is the same thing as A plus the grouping of B plus C. Again, this is called the associative property, that you can regroup however you want to group with addition, not with all operators, but with addition, there is the associative property of addition. So it could be a little bit confusing, the difference between the commutative property and the associative property. The commutative property is changing the order of the numbers. The associative property is changing the grouping of them. So hopefully that's pretty clear. And once again, there's a video talking about this. And the description below, there's a link. All right, so same thing. Next one, so using the properties from 1.1 and 1.2, which is the associative property and the commutative property, explain why this left side of the equation is equal to the right side of the equation. And then go ahead and compute the sum. All right, so the first thing we need to do is make the left side here look like the right side. So there's a couple of operations that we need to do, or a couple of properties we need to use to get there. First, we go ahead and let's go ahead and swap the order. We'll use the commutative property to swap the order of these two. So this is going to become 472 plus. Now let's swap the order of these two. We know we can do that with the commutative property. So let's do 28 plus 219. Okay, so we use the commutative property there. And now we can see that the numbers are in the right order. We have 472, 28, and 219. Now we can use the associative property to regroup. So now instead of grouping this together first, we can regroup and say 472 plus 28. So change that grouping plus 219. And now we have that side of the equation. All right, so now they look the same. And we use both properties to get there. So now let's go ahead and if we add it this way, that's actually easier to add than if we were to add this way. So if we first added 219 plus 28, we know how to add, we can do that. We come up with the right answer. There's nothing wrong with doing it that way. But if you're just wanting to do some mental math, take a look at this. Take a look at 472 plus 28. Whenever you see like an 8 and a 2, you know it's going to add together to make 10. So that should be something that it should be a trigger for you to know, like, oh, I got an 8 and a 2. Maybe we can add those together to make a whole number. I said I wasn't going to use the term whole number, and I don't mean that as like a whole integer. I'm just meaning like a power of 10 in this case. So 8 plus 2 would be 10, and it turns out that 72 plus 28 is actually 100. So 472 plus 28 is going to be 500. And that just adds together very cleanly versus adding something like this together first, which would not give you as clean of a number. So let's add this together first, because that gives you a much easier number to work with. Because once you have 500, then 500 plus 219, that's super easy to add. That's 719. All right, so same idea for this one. We're going to use the properties that we already know in order to make this easier for us. All right, so you could just add this from left to right. Do 2 plus 12 is 14, 14 plus 22 is 36, and so on. And you get the right answer. But there's a better way to just do this with mental math. You can pair together numbers to make them easier. One way to pair them together, you could say 2 plus 8, that would be 10. 12 plus 18 would be 30. That would be 50, and that would be 70. That would make this easier, because then you're working with multiples of 10, and that's a pretty easy way to add them. But an even easier way to add them is this top way of doing it, because if you do 2 plus 38, that's 40. 12 plus 28 is 40. 22 plus 18 is 40. 32 plus 8 is also 40. So they're all 40. So then you can do this nice and easy 40 times 4. If you didn't recognize that back here, that's okay. If you did recognize that you could do 2 plus 8 and 12 plus 18, that's great. That's a great start, knowing that you can add these up in any order that you want to make this easier. And then this would end up becoming 10 plus 30 plus 50 plus 70. And then you can add these two together. That's going to be 100. And what are you left with? 50 and 10 would be 60. And that'd be 160 also. So that's a decent way to add it too. This top way, these red lines are just an even easier way to add them together. But both ways are better than adding them one at a time. All right, so next one, find the sum of 1 plus 2 plus 3 all the way up to plus 19 plus 20. Okay, same thing as the last one. We can pair together numbers. So in this case, we want to pair together the 1 plus the 20 would be 21. 2 and 19 would be 21. 3 and 18 would be 21. And it turns out if you go through all of them, there are 10 combinations. If we wanted to go through them all, there's 1 plus 20, 2 plus 19, 3 plus 18, 4 plus 17, 5 plus 16, 6 plus 15, 7 plus 14, 8 plus 13, 9 plus 12, and 10 plus 11. Those are all the combinations. And that ends up being 10 combinations, which 21 times 10 would be 210. So this works when you have an even number of numbers. Is that right? Or is this an odd number of numbers? 1, 2, 3, 4, 5. Yeah, 20 numbers would be even number of numbers. If you have an odd number of numbers and you have something weird in the middle, you'll have, so if this is up to 21, for example, that final pairing, so you would have 1 and 21 would make 22, 2 and 20 would make 22, and so on and so forth. But then when you get to the middle, you would have an extra 10, I think, because you do like 11. Am I doing this wrong? Because 11 plus, or sorry, I think it would be 10 plus 12. Yeah, 10 plus 12 would be 22, but then you'd just be left with an 11 in the middle. So you'd have an extra 11 in the middle. That's not really relevant for this problem, but just know that if you had an odd number of numbers, if you had that 21 here, there would still be 10 pairings, but then you'd be left with this 11. So it would be 22 times 10, which would be 220. But you got to remember that you have this extra 11 that you need to account for. So now you need to do plus 11. So that'd be 231. Keep that in mind, because I think this question is going to be coming up in the future. All right, so using the picture below, explain why 2 plus 0 is 2. So this one's pretty simple. If you have 2 of something, and then you add none of something, then you still have the 2 of something. This is something that we're going to talk more about a little bit later, but know that if you add 0 to a number, then you get the same number back. And that's an important fact that we're going to have to use for things when we get into algebra. That is not true for all operations. If you multiply by 0, you do not get the same number back. So this is unique for addition and also subtraction, but there's some caveats to that we'll talk about later. All right, and that is it for 1.2. So go ahead and go into your textbook, and at the end of 1.2, there's a list of exercises. So go ahead and go through all of those exercises for extra practice. Can't hurt for extra practice, and see if you can use those commutative and associative properties and just get really familiar and get good practice with regrouping and reordering some things in order to make your math a little bit easier. The faster we can do this addition, the less of an issue it becomes when we get into algebra. Addition should not be something that is a hang up for us when we get into algebra. So I'll see you guys next time.